Hello dear students, this is grade 11 mathematics lesson on unit 9, further on trigonometric functions. This chapter is designed for natural science students. So today we focus on applications of trigonometric functions. So after revising this lesson, you are expected to apply sine law. So after revising this lesson, you are expected to apply sine law and cosine law in solving triangles and apply angle sum and difference formulas for determining trigonometric values for some angles. So let's continue to the lesson. First one is sine law. If we have this triangle with side A, B, and C, we can relate this side with its corresponding angle. Therefore, here the value of A, this length, divided by the angle corresponding to it, sine A. So A over sine A must be equal to B divided by the corresponding angle sine B. B over sine B, this equals to C over sine C. So this it is sine law. So in any triangle, the sides are proportional to the opposite side. Therefore, if this angle is bigger, the side opposed to this angle will be also bigger. This is the meaning. So now let's continue to the next part. The laws of cosine. If we have this triangle ABC with side A, B, and C, to find this length, you can apply this formula. A squared, this A squared is equal to B squared plus C squared minus twice of these two, BC, cosine of the corresponding angle A, cos A. Or if you are asked B squared is equal to A squared plus C squared minus twice of AC cosine of this angle B, cosine of B. If you are asked to find C squared will be equal to A squared plus B squared minus twice of these two sides to AB times cosine of angle C. So when the include angle, if the include angle is 90 degree, this will be reduced to Pythagoras theorem. If the angle is 90 or the include 90 degree, so the cosine law will be reduced to Pythagorean theorem. So let's continue. Let's see example. Look this one. If triangle ABC is given with side AB is 3 and side BC is 4 and the measure of angle B is given to be 60 degree, then what are the lengths of AC and cosine of angle A is asked. So to solve this, first we need to draw the triangle. So the triangle is given here. It's ABC. Side AB is given to be 3 and side BC is 4. Measure of BST is 60 degree. This is given. So to find AC, to find this side using cosine law, AC squared is equal to 3 squared plus 4 squared minus twice of 3 times 4 times cosine of 60 degree. So you'll have this one using cosine law. AC, side AC squared, or AC is equal to the square root of AB squared plus BC squared minus twice of AB times BC cos 60 degree. You have this one. So substituting the values, you have this. AB is 3 squared, BC is 4 squared minus twice of 3 times 4 times cosine of 60 is this half. When you evaluate this, you get square root of 13. Okay, now we are also asked to find the cosine of angle A. To find this cosine of angle A, we are asked to find this one. So we start from this. BC squared is equal to AB squared plus AC squared minus twice of AB times AC. Cosine of A So using this cosine law, you have this one, BC squared is equal to AB squared plus AC squared minus twice of AB times AC cosine of the included angle A. So this gives us BC is this 4 squared is equal to AB is 3, it is 3 squared plus AC, we have found AC, this side, AC, we have found AC to be square root of 13 here. So AC squared root 13 squared minus twice of AB is 3, AC is root 13 cosine of A. So from this, you will have this one. This will be this 6 root 13 cos A. Shifting to this side, you have this one. It is 6 root 13 cos A. This equal to 3 squared is 9 plus this one is 13, and taking this to this side you have minus 16. Therefore cosine of A will be, this result becomes 13 minus 16 is minus 3 plus 9 is 6. Therefore 6 over, you will have this one, 6 over dividing by 6 root 13, 6 by 6 cancel, you will have 1 over root 13. You will have 1 over root 13. Rationalizing, you will have the square root of 13 over 13. This is the cosine of the angle, okay? It's not the angle, it's cos A. Okay, now next, you'll have this one. The angle of elevation of the top of a building is found to be 60 degree. Top from a point on level ground. If the angle of elevation of a point on the building that is 3 meters below to the top is 45 degree as measured from the same point on the ground, and you are asked to find the height of the building. So here, this is the level ground. Assume this is the height of the building. So from this point, the angle of elevation to the top of the building is, it is 60 degree is given. The angle of elevation with top of building is to be found to be 60 degree, okay, to the top. And then if the angle of elevation of a point on the building, this assume it's a building. This is a building. So 3 meters below, assume this is 3 meters below this point. So the angle of elevation to this point is given to it is 45 degree. So you are asked to find the height of this building. That means the whole height. Assume this distance to be x. So we are asked to find 3 plus x. So from this we have two triangles, the bigger triangle and the smaller triangle. Let's use these two triangles. Using the bigger triangle, tan 60 degree gives you, assume this distance to be y, the distance from this point to this point, from the point to the building to be y. So tan 60 degree is equal to, it is x plus 3, this is the whole height of the building, x plus 3 divided by y. X plus 3 divided by y. So you have this one, root 3, tan 60 is root 3, this is equal to this, x plus 3 divided by y. We have one equation here. And tan 45 degree, using the smaller triangle, the smaller right angle triangle, tan 45 degree, it's opposite of our adjacent. So tan 45 degree, this is equal to tan 45, opposite x, adjacent is y. So it is x over y. Since tan 45 is 1, 1 is equals to x over y this shows that x and y are equal. So we have this second equation. So since x and y are equal, we can replace y by x here. You can substitute this equation to assume this second equation and this is the first equation. You can substitute the second equation on the first one and you get this. The square root of 3, this equal to x plus 3 divided by x, because x and y are equal, so I can say x. So solving this, x root 3, this equals to x root 3 is equal to x plus 3. So taking x to this side, you get this one. X root 3 minus x is equal to 3. Factoring x, you get this. Root 3 minus 1 is equals to 3. So x equals to 3 over root 3 minus 1. So this is the value of x. Therefore, the height of this building is 3 plus x. We have found x, therefore the height of the building will be 3 plus 3 over root 3 minus 1 here. So the height will be 3 plus x, so 3 plus x is 3 over root 3 minus 1. You can simplify this by yourself, so the height will be this one, this much unit, or 3 meters. So this much meters, the height will be this one. Okay, now let's see this example 3. Two drivers A and B leave the same place at the same time. If A drives 80 km per hour in the direction of 20 degree north of east and B drives 90 km per hour in the direction of south 80 degree west. So the question is, how far apart are they after 1.5 hours? So first, let's calculate the distance they travel after 1.5 hours. So in 1.5 hours, A travels the distance of 80, this is the speed, times the time in this one. This is 3 over 2. When you multiply these two, you get it is 120 km. It moves 120 km. And B travels distance of, its speed is 90 km per hour. Multiplied by 3 over 2, you get 145 km. So now let's draw the direction of these two motions. Here, A drives 80 km per hour in the direction of, in this direction. A moves in this direction, 20 degree north of east. So A moves in this direction. The degree measure is this, north of east. So you measure the angle from north to east. From north to east, this angle is this 20 degree. Okay, again B drives in which direction? South 80 degree west. So southwest, you measure the angle from south part, from south to west. This degree is how much? It is 80 degrees. So this is the path that driver B moves. And then we are asked to find the distance between A and B. So we have this triangle and we have this length. In 1.5 hours, B moves 135. In 1.5 hours, A travels 120 km, and in 1.5 hours, B travels distance of this 135 km. When you multiply this, you get 135. So putting this in graph, driver A moves 120 km northeast. Therefore, this one is 20 degree from north to east part. So the distance moved is this 120 km. And again, driver B moves from southwest, from south part to the west. Therefore, this is 80 degree and it moves 135 kilometer. So we are asked to find the distance between A and B. So applying cosine law, we can find D, but first we need to find this included angle. This one is 80 degree, means this angle is 10, and we have 90 degree here, and we have 20 degree here. Therefore 10 plus 90 is 100, plus 20 is 120 degree. Therefore here the included angle here is 120 degree. Applying cosine law, you will have this answer. D will be 120 squared plus 135 squared minus twice of 120 times 135 times the included angle. Cosine of the included angle is this 120 cos 120. Therefore, this will be, you get this result, and finally the solution set will be, it is the square root of 48,825, and evaluating this you get almost 221 kilometer. Okay, now let's continue. Let's see trigonometric formulae for sum and difference. The first one, sin x plus y is given by sin x cos y plus cos x sin y. In the same way, sin x minus y is given by this sin x cos y minus cos x sin y. And for cosine, cos x plus y is given by this cos x cos y minus sin x sin y. And cos x minus y is given by cos x cos y plus sin x sin y. For tangent, tan x plus y is given by this tan x tan y divided by y minus 1 minus tan x tan y. And tan x minus y given by tan x minus tan y divided by 1 plus tan x tan y. These are some formulas for sum and difference formulas for trigonometric functions. So double angle formula and half angle formula. Sin 2x is given by 2 sin x cos x. From this sin 2x means it is sin x plus x, therefore this is equal to this sin x cos x plus sin x cos x, sin x cos x. So this gives you 2 sin x cos x. And cos 2x is given by this. In similar way, you can find this one. Cos 2x is given by this cos squared x minus sin squared x, and tan 2x is also given by this 2 tan x over 1 minus tan squared x. And for half angle formula, you apply this one. Cos of x over 2 is given by this plus or minus 1 plus cos x over 2. For sine of x over 2 is given by this plus or minus 1 minus cos x over 2. And for tan x, you can have this one. Tan x over 2 is given by plus or minus the square root of 1 minus cos x over 1 plus cos x. You can find this one by multiplying. If you multiply the numerator by the square root of, let me show you this one here, the square root of 1 minus cos x divided by 1 plus cos x. If you multiply this, both numerator and denominator, by 1 plus cos x over 1 plus cos x, you will have this one. It is the square root of, the numerator becomes 1 minus cos squared x, and the denominator is this 1 plus cos x squared. From square root, this, since it is a square, it becomes 1 plus cos x. This 1 minus cos squared x is sin squared x, so it can be taken out from square root, it becomes sin x. So you'll have this one. You can do the same for this one by multiplying both numerator and denominator by 1 minus cos x. Okay, so these are the formulas, half and double angle formulas. Now let's try to apply these formulas. So here it says evaluate the following: sine 75, cos 105, tan 15, sine 22.5 degree. Let's start from this one. To find sine 75, we need to write this 75 as the sum or difference of two special angles. So sine 75 can be written in this form: sine 30 plus 45. So this equal to this sine 30 cos 45 plus sine 45 cos 30. Therefore, when you evaluate this, sine 30 is 1 over 2, cos 45 root over 2 plus sine 45 is root over 2 times cos 30 is this root 3 over 2. So simplifying this, you will have this one, it is root over 4 plus root 6 over 4. Now the next example is this one, cos 105. Cos 105 can be written as a sum of two special angles, 45 and 60. So it is written cos 45 plus 60. Therefore, this will be equal to cos 45 cos 60 minus sine 45 sine 60 using the formula. Cos 60 is, it is half, and cos 45 is root over 2 plus sine 45 is it's root over 2 and sine 60 is root 3 over 2. So this one is not plus, it is minus. Therefore, this is root 2 over 4. This one is minus root 6 over 4. This will be the answer. For tan 15 can be written in this form: tan 45 minus 30. So using the formula tan 45 minus tan 30 divided by 1 plus tan 45 tan 30. So this gives you tan 45 is this 1, tan 30 1 over root 3 divided by 1 plus tan 45 is 1, tan 30 is 1 over root 3, 1 times 1 over root 3 this one. So simplifying this, you get root 3 minus 1 over root 3 plus 1. Sine 22.5 degree, in this case half angle formula, sine 25 degree can be written in this form: sine 45 over 2. Therefore, using half angle formula, sine 45 over 2, this equal to 1 minus cosine of cos 45 divided by 2. So this equal to this 1 minus cos 45 is this root over 2, or I can say 1 over root 2, they are the same, 1 over root 2 over 2. So this gives you root 2 minus 1 over 2 root 2. Okay, summarize. To solve triangles, we can use either sine law or cosine law, and maybe trigonometric ratios. And we have also said these formulas sum and difference identities. Sine x plus or minus y is given by this equation: sine x cos y plus or minus cos x sine y, and cos x plus or minus y is given by cos x cos y, if it is plus minus, if it is minus plus sine x sine y, and tan x plus or minus y is also given by this tan x plus tan y over 1 minus tan x tan y, or for minus case you use the lower one, tan x minus tan y over 1 plus tan x tan y. So I'll give you exercise for you. Please do exercise 9.6 on page 391. So this is all about today's lesson. Until next lecture, goodbye.